So we talked about ratio as one of the interpretations of a fraction way back in the beginning of this chapter. So sometimes a ratio is written with a colon in between, but that means the same thing as saying, for example, 2 to 3, or you could write it as a fraction, 2/3, one order, 2/3, 2/3. So all of these mean the same thing. The difference about a ratio is the interpretation. Ratio isn't necessarily part of the whole, it's just the comparison of two parts with division. So this could be, in a classroom, there could be 2 boys for every 3 girls in terms of the distribution of gender. Now, that doesn't mean 2 out of 3 people are boys. That's a different kind of use of fraction. That's part of the whole. Here, it's just 2 different things being compared. Okay? A lot of times, we'll use ratios when we're talking about recipes. So, for example, 3 cups of flour to 1 cup of water.
Oh, that's making rice.
Rice, yeah. So with rice, I make brown rice, it's going to be 2 cups of water to 1 cup of rice when I make rice. When I make pizza dough is 3 cups of flour to 1 cup of water. Right? And there's some other things, so you can have ratios of more than just 2 things also. You can chain 2, 3, 4 of them together. It looks kind of weird fraction-wise, but ratio-wise it makes kind of sense. So we're mostly going to stick with a ratio of 2 things because it makes sense as a regular fraction. But you could have a multi-ratio. So something like 3 to 1 to 1 again. And this could be the ratio of flour to water to oil in my pizza dough recipe. And they don't have to be the same unit, because this would be cups of flour, this would be cups of water, or maybe this is tablespoons of oil. So pretty much any recipe is just a big, long ratio. Use things in this ratio if you want it to come out right. Right? If you double one, you double them all. You cut one in half, you cut them all in half. Okay? Which is the idea of similar fractions, that equivalent fractions we talked about way back in the beginning. Now, when you take a ratio and you compare it to another ratio, that's when you get a proportion. So comparison to ratios is a proportion. So 2 is to 3, as say 6 is to 9. So then given any 3 parts of a proportion, we can find the fourth. Now, connecting this back to the geometry we've been blending with playing with fractions, similar figures have proportionality going on in them. You may have in your past life in math talked about a geometry in a class where they talked about similar figures versus congruent figures. So congruent would mean they're exactly the same shape and size. Similar figures, just the same shape.
So would that be like a square and a rectangle?
So no, they have to
Because one
be.
is longer.
So a square and a rectangle would not be similar. because they're not the same shape. So same shape have to have proportional side lengths. So if I start off with a rectangle that's 1 unit by 2 units, so something about that size right there, to be proportional to that, if I take and double, say, that short side, I would also have to double
The top side.
the top side. So it's proportional, this one would be 2 to 4. And so the proportional side lengths means if you set up a ratio could be length divided by width. So if I say the length of the first one is 2 and its width is 1, that better match be equal to the same ratio of the other one, its length divided by its width. If they're not the same, they're not proportional. And the thing about a square, the ratio of sides on a square is always 1 to 1. Even if I made a bigger square, room here, if one side was 2, the other side would have to be 2. 2 divided by 2 is still a ratio of 1 to 1. So popular triangle, 30, 60, 90 triangle. So it has a right angle in it. And then in one other corner, there's a 30-degree angle, and the other side's a 60. So I'm guessing that's about 30 degrees. That one's about 60 degrees. And there's my 90-degree angle right there. So if you draw any other 30, 60, 90 triangle based on some different side length,
It's wrong.
no, it's going to be similar to this one right there in that the side lengths are proportional. So if I'm sure that's a right angle and I'm sure that's a 30-degree angle up there, the remaining angle would have to be 60. And so let's say the height, there's use the right colors. Whatever the height of that one is versus say its base here, the ratio of the height of this one to the base of that one has to match. They've got to be the same. Otherwise, if they're not, then one of them's not a 30, 60, 90 triangle. Because they have to be the same shape. Right? So the same shape is like shrinking something or blowing it up, but not distorting it.
Not stretching it.
Yeah, not stretching one direction, but not the other. Correct. Yeah. All right, so another place ratios and proportions come in are images, pictures and videos. Pictures and videos.
That the thing they put on the bottom where it's like 120 times something else.
Yeah, so like, yeah, exactly. So common high definition TV screen is going to have what we call an aspect ratio. Of 16 to 9 is the common high definition aspect ratio. Now, often they'll talk about, instead of giving a number like 16, they'll say how many pixels across it is and how many pixels high it is. So sometimes it'll be given that way. The ratio, aspect ratio is a very specific ratio. It's always the ratio of the width to the height. And if you think about it, most TV screens are wider than they are tall, right? Now, interesting thing about even though when images are created for TV, they have to fit a certain aspect ratio, right? But TVs come in all different kinds of sizes. And usually when you look at the size of a TV, they give the diagonal length. Now they'll also give the length and the width, but they'll usually give the diagonal length.
Why?
You know, I can't remember the history of where that comes from. I don't know. Maybe I knew it one time in my life, but I don't now. But generally, when you look up TVs, they'll say, hey, this is a 55-inch TV. This is a 40-inch TV. They just give one number to describe the size of the TV. And it always refers to the diagonal. Now, but screens can be different shapes, right?
Yeah.
You can have a 55-inch TV that looks more square.
Yeah.
You could have one that looks more rectangular, right? So there's all kinds of rectangles and squares that are going to have a 55-inch diagonal. Usually with high definition, though, it's also going to have an aspect ratio of 16 to 9.
Now, when you do ratios and proportions, is the first one always on top and the second one always on the bottom?
Yeah, so as a fraction, this would be written as 16 over 9.
Even though it's improper?
Doesn't matter, yeah.
Okay.
Yeah, proper or improper, yeah. So when you state a ratio, it's always numerator, colon, denominator.
Okay.
When you state a ratio using the colon.
Because I remember like when I was doing the 6-4 homework,
yeah,
and they did application processes, you had to put a variable in.
Yeah.
So that's where I was like getting sketchy a little.
Mm-hmm. Okay. So we're going to do a little algebra that we usually don't do. So we're going to see if we can solve the problem of if we know we have an HD TV and we're given that it's a 55-inch TV, can we figure out the length and the width of the TV?
Yes.
Okay, so that's what we're going to try and do. So given that we have an HD TV, it's probably this bottom shape there and not that shape because that's more square-like. It's definitely not 16 to 9. And this shape right here, that's not quite even 16 to 9 either. That looks more like 4 to 3 maybe. 6. Yeah. But there's lots of different aspect ratios out there. So
Just
do a quick search. What's that?
There's 3 inches of snow so far.
Really? No.
Over by, at Fabian School at Sherwood, up by Burger King.
Aspect ratio TV. What's this one? Yeah, so here, this site here shows some different aspect ratios. Let's see. So 16 to 9 is this middle one here, and that's the typical HD TV ratio. But TVs come in all kinds of dimensions, and they don't necessarily fit that 16 to 9 ratio. 4 to 3 was what used to be more common. Mm-hmm. So back when I was a kid, most TVs had a 4 to 3 ratio. Yeah. But movies in the movie theater had a 16 to 9 aspect ratio. And so whenever they took a movie from the movie theater and put it to go on public television or broadcast television, they had to either crop it or do what they called letterbox, where you got the black bars across the bottom and the top, like that image in the middle on the right.
I remember that's what happened when we got widescreen on one of the movies.
When they say this film has been formatted.
Yeah, right, yeah, so it used to be that way. And so they had to make one of two decisions. They had to either, if they wanted to show everything that was filmed, they had to make it wide enough that you lose height, right? Or if they wanted it to fit nice, like the bottom right image right there, they had to cut out stuff on the edges, which meant you could miss parts of the scene if whoever did that didn't do it right, right? And so it's an interesting thing. So it's not so much a problem anymore, but it used to be. But still, they're given all the different movies, society has collected over time. There's all different kinds of sizes out there for these things. All right, so let's play around with this problem. So new page, let's write what we know. We know we have an HDTV. So the aspect ratio is, I'm going to write it as a fraction, 16 to 9. So that's a ratio of the width to the height of the TV. Okay. Now, we've also been given information that it's a 55-inch TV, and that 55 inches refers to the diagonal. All right, so let's sketch this out. So I'm going to guess, say that's about 9 right there. There's another 9, and then 7 more. So this is about my best approximation of a 16 to 9 rectangle. And I have this diagonal running through there. And I know for sure that's 55 inches. So I want to know what width should we have here and what height we should have there so that we have the right shape rectangle. And the aspect ratio determines the shape of the rectangle. And this aspect ratio means it's not square, it's not super skinny, it's just somewhere in the middle, whatever 16 to 9 is. So putting this together, does anybody from their past life remember a relationship between these perpendicular sides and the diagonal?
Isn't it 2 times length or 2 times width?
That would be the perimeter,
okay,
not the diagonal.
Equal something squares.
Squares, Pythagorean Theorem.
Oh, wait, a squared plus b
Yeah, there you
c
go.
squared.
Yeah. So-
A.
Yeah, Pythagorean theorem tells us that if these two are at right angles to each other, then they have to have the following relationship, that the width squared plus the height squared has to equal the diagonal squared. Right, and that's the Pythagorean theorem. So we know there's one relationship between our variables. The aspect ratio gives us another one, okay, up top here. The aspect ratio says, hey, but the height and the width always have to have this proportion.
And they have to be equal, so.
Well, the ratio has to be equal, right? But it doesn't tell me what either number is. However, if I put all this together, let's see, I'm going to say I like the width, so I'm going to solve this for the width. So if I take that top equation, to get the width alone, I would have to multiply the height over to the other side. So then I would get 16 ninths times the height. And this makes sense to me because I know my width is supposed to be bigger, so I'm multiplying the height by a fraction that's bigger than 1. It should scale it up to match the width. Putting these together, what I can do next is I can replace the width with what that aspect ratio says it ought to be. So I'm rewriting this equation right there. So instead of plugging in a W, I get to plug in 16 ninths H. So that gives me 16 ninths H squared. Why squared? Because the W has to be squared. So that represents this side right here. Pythagorean theorem says, add on that other side squared, and that's going to equal the diagonal squared. All right, so I'll help you solve this. Next thing we need to do is kind of clean up this part right here. And calculator help from one of you might be nice. So again, we started off with 16 ninths H squared. We want to carry the square through there. And we have a property that says if you square a product, that means both pieces are squared. So I need to know what is 16 times 16. I think it's 256.
Wow. Oh, you're good.
Some days. 9 squared, 81. And then H squared.
Squared.
Is H squared. Plus, we have that lone H squared just hanging out, right? Pythagorean theorem. And the 55 squared still chilling on the other side. That one I can't do off the top of my head easily.
30-25.
30-25, okay. Put that in.
I did not do that in my head.
That's right. 30-25. So on this left side here, I have a pair of like terms because they have the same variable to the same power. So here I have this fraction of h's, and here I have 1h. To add those, I need a common denominator. What should the denominator be? 81 is my denominator. So how do I rewrite 1 in terms of 81s?
Times by
81 over
Yeah,
81.
81 over 81. Okay, so now I have, oops, on pen, 81 over 81 h's plus 256. That again. 256 h over 81 inches. Or h squared. All right, so let's see, 256 plus 81, that's going to give me a 7 and 337 over 81, I think. 81 plus 256, how do I do?
That's right.
Almost done. How do I break? I need to get h alone, so I got to break that multiplication. How do we get rid of multiplication? We have two options here.
Right.
We could divide by that fraction, which is the same thing as multiplying by the reciprocal, because we're working with fractions. So I'm going to choose to look at it as multiplying by the reciprocal. I'm going to multiply both sides by 81 over 337. That's going to get a little messy on the left side, but I don't care too much. So let's clean this up just a little bit. Expression. Okay. Now the key here is I finally got the h alone. Sort of. It's an h squared is equal to this calculation over there, whatever that happens to be. 3025 times 81 over 237. We'll throw that in the calculator in a minute. Anybody recall the opposite of a square? Square root. Got it. Yeah, so it looks like the height is going to be the square root of that interesting number right there. Calculator time.
245,200. Oh yeah, no, 239,025. Over 337.
Okay, so yeah, so if I just do the fraction, I get about 727. And I want to know what the square root of that is. And so cleaning it, again, dividing by 337, it's probably not going to go into this evenly, which is all right. But I want the square root of that. Let's see, I think I'll probably start over. So I'm going to write square root 3025 81 divided by 337. So I get a height of about almost 27 inches. Yeah.
Which kind of makes sense.
So coming back here, so it looks like we think our height is about 27 inches, and that sits in that ratio of 16 to 9.
So you just plug that in?
So 27 actually is kind of a nice number given the 9 there. 9 goes into 27 how many times?
3.
3 times. So therefore, since this is 3 times the 9, the width should be 3 times 16 to keep them in proportion. So I'm estimating that the width's going to be 48-ish. Can you help me out? 3 times 16?
Yeah, 48.
48? Yeah, so I think the width's going to be about 48 inches. Okay, so I'll double check how I got that. So again, if this is a high-def TV, then the width to the height has to be in a ratio of 16:9. So usually when I write down a proportion, I write down words or letters that state what the numerator means, and words or letters that state what the denominator means. Which did we calculate first, the width or the height? We got the height first. Yeah, so we calculated the height to be about 27, so we can then solve this proportion and get the width. There's two ways to do this. One way is to say how many times is it to get from the original to the new one. And we can see, well, 9 goes into 27 3 times. If we want these to be equal, we would have to do the same thing in the top. So that's one way to look at proportion. The other trick we have for solving a proportion is cross multiply and then divide. So then I would cross multiply, get that 16 times 27, and divide by the 9 and get my missing number. And when I do that, I can see that the 9 goes into the 27 3 times. So it gives me that same idea I had earlier. It's going to be 3 times that aspect ratio width. So it's about 48.
So are there any mixed numbers in ratios and proportions?
Absolutely, yeah. So for example, our number wasn't actually 27. It was 27.96, blah, 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 blah. We just chose to round. We could have left all the decimals in there. So they don't have to be whole numbers. Okay. So they could definitely be fractions within fractions. So let's just double check this with the Pythagorean theorem. So we think if we have a height of 27 inches, we should have a width of 48 inches. The TV was advertised as a 55-inch TV. Do these numbers go together? Now we did surrounding, so it's not going to be perfect. Pythagorean theorem says take that 27 and square it, take that 48 and square it, add them together. That should be about the same as 55 squared. Now normally it's going to be exactly the same, but we rounded stuff, so it's not going to be exact. So let's test that out. So calculator, 55 squared, that was that 3025 we had earlier. And I want to compare that to 27 squared plus 48 squared. And that should be in the ballpark. So we're close, 3033 instead of 3025. Keep in mind that's a little high because I rounded the 26 up to a 27, right? And then the 48 came from that. So we're in the ballpark. Yeah, so interesting thing, most TVs these days have an aspect ratio of 16:9. Do all of them? Answer is no. So what happens to the program you're watching if your TV isn't 16:9, but what you're receiving to play is supposed to be 16:9? One of 3 things happens. Back to this picture over here.
I changed the format.
Either some stuff's going to get cut off, or it's going to get distorted, or you're going to have some extra space somewhere, right? And that's the only things that can happen. And usually TVs let you choose. There's a menu setting somewhere that says, what do you do if the programming coming in doesn't match the dimensions of the TV? And there's different ways that does around it. You'll either crop a little on the edge, leave a little space top and bottom, or distort it. Hopefully the distortion's not too bad. All right, so...
Wait, I have a quick question.
Yes, what's up?
When you did the W equals the 16 over 9 times H,
Yep.
like at the very beginning, where'd you get that from? Like, yeah.
Okay, so that came from the aspect ratio that I started with over here.
Oh.
The 16:9 has to be the width to the height, so I just solved that for the width. I'm multiplying the H over to the other side.
Oh, okay. That makes sense.
Yeah, so that allowed me to mesh the diagonal measurement that usually, when you look at a TV box, that's what they're going to tell you, versus checking to see if it has the dimensions of a high-def television. Now, usually what'll happen is on the front of the TV box, it'll say it's 55-inch, and on the side of the back, it'll state the actual length and the actual width. So if you ever buy a TV, it's not a bad idea these days to double check. Take the width and the height they give on the side of the box, whip out your calculator, divide the two, and hope it comes up to close to 16:9. That means it'll fit with most modern programming nicely. Okay, so that was about the hardest proportion problem we could deal with, because we also threw in the Pythagorean theorem. Let's take a look at a medium type problem.
What else do they use ratios for? Besides baking and cooking and TVs?
In my opinion, the most powerful piece of mathematics in existence is ratio and proportion. Right? If you drive your car and look at the speedometer, you're looking at a ratio, distance to time, right? When your car shifts gears, it's changing the gear ratio so that the same amount of power is going to give you more distance, right? Or less distance if you're going uphill because you got to gear down.
What about like betting, like 17-1, so how many dollars?
Oh yeah, so betting comes up in a couple of different ways. So with gambling, there's just, we're going to get into this in a later chapter, but a quick note on gambling. So with gambling, there's probability, right? Probability, and probability is just favorable outcomes over total outcomes. Okay, so maybe it's a horse race, and the horse has a probability of winning of like, I don't know, 1 to 10. So that means it won 1 out of every 10 races it's done in its lifetime, maybe. Then there's the idea of odds. And odds is a ratio of favorable to unfavorable. And that's what they use in terms of gambling if you place a bet to figure out how much you should win. Unfavorable. So the odds ratio for winning for this horse would be 1 to 9. So for every 1 race it won, it lost 9. Whereas this one says it won 1 out of the 10 races it ran, right? They're related, but a little bit different. And so if I were to bet money on this horse, then I would expect for every $1 I bet, I would win $9. And that's usually the way the payout goes. Now, what they'll do is they'll actually alter this a little bit so that the house that's making this bet with you gets to make a little money off the edge. So they'll lower that from 1 to 9 to maybe 1 to 8. So they make a little, otherwise they're losing money in the business, or they're breaking even. And in which case they have no business.
That's almost like the lottery where they take out the taxes.
So they would actually lower it to be 1 to 8. So even though they expect the horse for every 1 race it wins to lose 9, they will actually pay out $8 for every $1, which then evens things out for them, so they make a little bit. Okay. So you might win 8. A bunch of people lose $1, but they gain $1 in the process too, so they can stay in business.
Do they use ratios a lot when they do like standardized testing for like different schools and all that? To find the percentage of.
That's yeah, I guess everything can be considered a ratio. So in standardized testing, they give what's called percentile rank.
Yeah.
And we'll talk about that in the statistics section next quarter.
We're just rushing this stuff.
Yeah, you're rushing ahead there. Yeah, so that's a little, it is a fraction, but I wouldn't really, it's different than the way we're working with fractions right now. It's more straight percentage.
So is our GPA like a fraction too?
Your GPA is a weighted average. Which is another idea we'll talk about next time. Okay, so let's take a look at one more problem here, and then we're going to call it quiz. Yes, I want to continue, please. All right, so homework problem number 6 looked like this. Let's see if I can clip it. So I had a question on this one. And it is still snowing out.
Yes, we have about 3 inches like they said so far.
A couple years ago, I live on above Main Street, above the river, and there was enough snow 2 years ago in one night that no cars could possibly go up my hill because it was so steep. So I get to hike up and ski down it, and it's a steep hill. So I was like, whoa, I've never gone that fast.
Damien was, not Damien, but one of the other kids started on the top of the hill over by the college and sledded all the way down because Damien and I have never sled yet. So he thought it was the coolest thing watching this guy go like all the way down to the bottom.
Oh, yeah, that is pretty awesome, skiing, sledding down the hill. I had a horror story a couple of years ago with kids sledding on my hill. I'll tell you after the video. All right, so let's take a look at this. So we have a ratio of two positive numbers of 5 to 6. And then they give us some information about the numbers, and we want to see if we can come up with what the numbers is. So part A, so let's just call the numbers x and y because they don't give us much else to go on. So the ratio of x to y is 5 to 6. So that's the initial information for the whole thing. Part A says, let the sum be 132. So then they're telling me x plus y equals 132. So this is a lot like that Pythagorean Theorem TV problem we just did, except it's a little easier because nothing's squared. And the key is, if I know the ratio between the two numbers, then I can tell you what one number looks like compared to the other by just taking this y and multiplying it up to the other side. So x would be equal to 5/6 of whatever y is. So if you tell me what you think y is, I can use this to say, hey, x should be whatever. Like if you said y was 6, 5/6 of 6 would be 5. I'd say, yeah, x has to be 5. If you said y was 12, 6 goes into 12 twice, 3 times 5 is 10, x would have to be 10. Okay? But we can't just guess at y, we have to use this over here. And what we've done is we've just said, hey, x is always the same thing as 5/6y. So we just do a little substitution right there. So we're just going to replace that x in the other equation with 5/6 of y. We still have that other y hanging out, right? So I have that other y being added on, and that's 132. So putting these two things together, I've now narrowed it down to just talk about y. Okay. So I have 5/6 of y plus 1y.
You do the reciprocal of 6 over 6, don't you?
I'm not ready to do that. Oh, we want to turn 1 into a denominator of 6. I see what you're saying, yeah. So 1 would be 6/6 plus 5/6 gives us how many sixths? 11/6. And now we can break that multiplication by multiplying by the reciprocal. So we could say we're dividing by 11/6, but it's easier to just multiply by the reciprocal. This is our division algorithm. Let's see, I think 11 goes into 132 12 times. 12 times 6 is 72, maybe? Can you help me out on that?
Checks out.
So according to putting these two facts together, I get y is 72. Now, once we know y, we can go back and say, oh, well, I know how to find x given y. Take 5/6 of that number. Let's see, 6 goes into 72 12 times. 12 times 5 is 60 on a good day. Yeah, so it looks like, and they want the smaller number first. So the smaller number we believe is 60. And the larger number we believe is 72. Now just double check this. What's 60 plus 72? 132. And what happens if we take 60 divided by 72? What should we get?
5/6.
We should get 5/6, right? So we can do that division and just double check. Yeah, so it's just a matter of putting together the ratio with another fact to get a complete picture of what's going on. Kind of like the TV aspect ratio. Well, yep.
It's
It
definitely come a
is.
long way from just two things that you cross multiply and there's your answer.
All right, so I'm going to stop this here. That's my overview of ratio and proportion. Bye-bye.